If you have a below average GMAT score, this video isn't for you. If you have an average GMAT score, this video still may not be for you. This video is for people who already have a good GMAT score, but want a great one. I'm Erika with Target Test Prep, and today I want to share one of the main ways that GMAT differentiates good scores from top scores, and how you can defeat it to get a great GMAT score. If you're already scoring in the top quartile or so, you likely know that the test follows specific patterns, reuses specific tricks. If you see statistics on critical reasoning, you're looking for ways those statistics could be misleading. If you see the word non-negative on a quant question, you're thinking about the impact of zero. If you see something with the format a squared minus b squared, you're using the difference of squares formula to expand. These are classics for a reason. They appear frequently, and recognizing them quickly can fast-track the solving process. However, while a familiarity with these archetypes can take us from a below-average score to an average score, or an average score to a good score, they can get us into trouble at the upper end of the score range. And that's because the hardest questions on the test like to take our usual strategies and flip them on their heads. Let me show you what I mean in a couple example problems. Here's a reading comprehension question from a recent video I did breaking down one of the hardest passages in the Target Test Prep program. If you haven't seen that video, that's okay. Knowing that this is an assumption question, take a second to look at the answer choices. Without knowing anything about the passage, which answer choices are you drawn to, and which ones feel the most unlikely? Pause the video if you want a moment. If you're anything like me, you immediately clue in on the sometimes in answer choice D. That is an excellent word for an assumption question. It's nice and vague, which makes it much more likely to be definitively true, which is what we're looking for in an assumption question. Conversely, the strong no in answer choice B jumps out as extreme and unlikely to be something that must be true. And that is completely wrong. When we compare against the passage, it turns out that the thing in answer choice D never happens. So despite its promisingly non-committal language, D is not our answer. Similarly, answer choice B is explicitly supported by the passage. 0 multi-celled organisms do this, making B our least likely candidate our correct answer. You can check out the video this question is from for a full breakdown of the passage and a complete explanation of this question, along with 2 other super hard questions from the same passage. Here's another example. This data sufficiency question is featured in my #1 hardest data sufficiency practice question video. This question asks us about average speed, or total distance over total time, across a 2-leg trip where each of the legs is the same distance, and whether that average speed is at least 60 miles per hour. This leads us to the equation 2d over t1 plus t2 is greater than or equal to 60. With that in mind, take a quick look at the statements. Don't do any calculations, just a quick look. What are your instincts about sufficiency? Again, feel free to pause the video. I notice what appears to be a typical setup with 2 seemingly obviously insufficient statements. Statement 1 gives us the value of a single variable, classic insufficiency, while statement 2 gives us the ratio of 2 variables but no actual values, something that is usually also classic insufficiency. So at this point, we think the game is determining whether the statements are or are not sufficient together, so whether the answer is C or E. And that's also completely wrong. If we actually follow through and manipulate statement 2, plug it into the inequality from our question stem, and simplify, it gives us the inequality t2 is less than or equal to 0, which for a speed is impossible. Car travel is by definition not instantaneous, which means that despite fitting the paradigm of a ratio that gives us no concrete values, statement 2 definitively answers the question with a no, making it sufficient on its own, giving us a correct answer of B, an answer choice most good test takers eliminate immediately. If you want to see the calculation I referenced, plus a more in-depth explanation of the solving approach, I recommend checking out the original video. So in both of these examples, we see that the strategies that work on medium difficulty questions or even medium hard questions work against us on very hard questions. And that's on purpose. The test maker has intentionally designed these questions with the goal of determining whether we over-rely on our knowledge of what the test usually does versus apply an extra layer of criticality to the specific problem at hand. Moral of the story, as you get closer to the top of the score range, avoid complacency. Rather than taking the test tendencies as a guarantee of something specific, take them as a clue to pay attention in general. Let us know if this video helped you by giving it a like and subscribe for more expert advice. Thanks for watching, and I'll see you in the next one.